Welcome, nocturnal minds, back to our class. Oh, you are really study hard. So, picking up from our discussion on the landscape of science after Quine, we naturally arrive at a field that often seems to be its shadowy counterpart, or perhaps its foundational bedrock, metaphysics. At its heart, metaphysics is grappling with the most fundamental question of all: what is there? It's not just about what we can observe and measure, it's about the very nature of existence itself. Think about it: universals like redness or causality, the persistence of objects through time, the possibility of other worlds, even the nature of identity itself. These aren't just philosophical curiosities. They touch the core of what any scientific theory implicitly assumes about the world it describes. Even debates in specialized areas, like the mind-body problem, or the existence of abstract entities, like logical forms, fall squarely under the metaphysical umbrella. Now here's where things get interesting. Both science and metaphysics seem to be chasing the same elusive prize, a true description of reality. But if they're aiming for the same target, how do they differ? Is one just a more sophisticated version of the other? Or are they fundamentally different beasts? Philosophers have wrestled with this for centuries. You've got the spectrum of views. On one end, you find folks who basically say metaphysics is just intellectual fog, a waste of time. On the other end, you have those who argue that without a solid metaphysical foundation, science itself is built on sand. So, the big questions are, can we draw a line between them? And if so, what does that line look like, and how do they interact? Let's rewind to the beginning. Aristotle, the OG, didn't call his work metaphysics. He called it the study of being qua being, basically the nature of existence itself. His goal was ambitious: to figure out what it means to exist, to categorize everything that exists, and understand how these categories relate. This wasn't just about rocks and stars, it was about the most general features of reality. The name metaphysics came later because his book happened to come after his physics in the collected editions. But, as Mumford points out, this is almost too neat. It suggests metaphysics is literally after physics, but also, coincidentally or not, above or beyond it in subject matter. Aristotle's focus was abstract, general being moving beyond the specific empirical details of physics. Before Aristotle, Plato was busy with his forms, and the pre-Socratics were already wrestling with deep metaphysical puzzles. So, while the label stuck, the idea of metaphysics being distinct, perhaps more fundamental, was there from the start. And let's just note the slight terminological quirk: we call practitioners physicists, but not metaphysicists. Maybe they should be called metaphysicists, just saying. Fast forward a few centuries, and thinkers like Francis Bacon start looking at how science actually works. For Bacon, it wasn't just about the content of knowledge, but the method. He envisioned a systematic, almost mechanical process, the novum organum, or new instrument. The idea was to move rigorously from observing specific facts, tabulating them, and then deriving general laws or theories. Think of it like a recipe for generating scientific truth. Later, the empiricists, heavily influenced by Locke, doubled down on experience as the sole source of knowledge. Their principle became quite strict: if you want to claim an idea is legitimate, you have to show exactly which experiences gave rise to it. If you can't trace an idea back to some sensory input, then, according to them, that idea is just floating free, illegitimate. This sets the stage for a very skeptical view of anything that doesn't seem to come directly from observation. This leads us straight into the heartland of logical positivism, particularly as articulated by A.J. Ayer. They took the empiricist idea of verification and ran with it, making it the ultimate gatekeeper for meaningful statements. Drawing heavily on Hume's famous fork, they argued that a statement is only meaningful if it's at least in principle, empirically verifiable. So, "there's a cat in my room" is meaningful because, in principle, I could see cat-like things in my room. But what about God exists? Well, God, according to this view, is outside space and time, invisible, unheard. You can't point to any possible experience that would verify such a claim. The conclusion: not just false, but meaningless. The words are just empty noise. Now, they made an exception for logic and mathematics, calling those trivial relations between ideas. But for anything substantive and non-empirical, like metaphysics, the verdict was harsh nonsense. Ayer even provocatively suggested we should eliminate metaphysics entirely. Sound familiar? It's essentially Hume's old argument, updated for the 20th century: burn the books. If it's not abstract reasoning about numbers or experimental reasoning about facts, it's just sophistry and delusion. Enter Karl Popper, a major critic of both the Baconian inductive method and the logical positivists. He saw two big problems. First, induction, no matter how carefully done, is logically flawed. You can never be absolutely sure your next observation won't contradict your general rule. Second, and crucially, general scientific theories like all swans are white are never truly verifiable. You can't check every single swan in every possible world. So, using verifiability as a criterion for science, as the positivists did, would mean declaring all scientific theories meaningless. That couldn't be right. Popper proposed a different criterion: falsifiability. A theory is scientific if it makes predictions that could potentially be proven wrong. You can always find observations that support a theory, but a good scientific theory must be vulnerable to being refuted. If a theory is unfalsifiable, it's not scientific. This was a clever move. Unlike the verificationist criterion, the claim that falsifiability is the key to science isn't itself falsifiable. It's a philosophical stance, not a scientific one. This allowed Popper to sidestep the self-defeating nature of verificationism and, importantly, to argue that metaphysics, while not scientific, could still be incredibly important. He famously used this to attack unfalsifiable theories like Marxism and psychoanalysis, branding them pseudosciences. A victory for Popper over the positivists. But hold on, is falsifiability the magic bullet? Not so fast. Popper's account faced its own set of challenges. Consider existential claims statements like there is a fifth force or there exists a particle X. These have the form there exists something that is F. You can potentially verify them, find the force, find the particle, but you can never falsify them. No matter how many times you don't find it, you can't definitively say it doesn't exist. Then there's the Quine thesis, which basically says theories don't stand alone. When an experiment fails, you can always blame something else. Maybe the equipment was faulty, maybe the auxiliary assumptions were wrong, maybe the observer made a mistake. It's often easier to tweak the supporting cast than to admit the star play, the main theory, is flawed. Think of the black swan example again. Seeing one black swan doesn't automatically falsify all swans are white. You might just say, well, this one must be special, or I misjudged. This leads to more holistic views of science, especially prominent after Kuhn, Lakatos, and Feyerabend. They saw scientific theories not as isolated hypotheses, but as whole packages, paradigms, research programs, or even ideologies. Observation itself becomes theory-laden. What you see depends on the theory you already accept. If that's true, then how can we ever truly falsify a theory? It starts to look like both science and metaphysics might be equally resistant to empirical refutation, blurring that line again. Okay, if verification and falsification both stumble, maybe we need to rethink the whole premise of a sharp divide. Let's look at the traditional view of how people thought metaphysics and science differed. The classic picture painted a clear contrast. Metaphysics was seen as substantive. It made genuine claims about the world's structure. It was synthetic. Its truth wasn't just about the meaning of words, but depended on how the world actually was. And crucially, it was a priori, supposedly discovered through pure reason, without needing empirical input. Science, on the other hand, was seen as purely empirical, discovering truths a posteriori, through observation and experiment. The implication of this setup: competing metaphysical theories, like the bundle theory versus the substratum theory of substance, couldn't possibly disagree on observable facts. They'd predict the same results for any experiment. So, choosing between them couldn't be based on empirical evidence. It had to be a matter of pure reason, a rational choice between competing conceptual frameworks. Spinoza's Ethics is often cited as the prime example of this rationalist approach, building a complete system from first principles via deduction. But here's the rub, the puzzle that really gnawed at philosophers. How can you possibly know substantive synthetic truths, claims about the actual world that aren't just definitional tautologies, purely through a priori reasoning without any empirical input? Think about it. Logic and mathematics are a priori, sure, but they're insubstantive. Saying if A implies B and B implies C, then A implies C doesn't tell you anything about whether A, B, or C actually exist in the world. It's just about the relationships between ideas. But metaphysics clearly aims higher. When a metaphysician says universals exist, they're not just defining the word universal, they're making a claim about the actual structure of reality. Its truth hinges on whether universals are real, regardless of what we mean by the term. This combination, being substantive and synthetic, yet claiming a priori knowledge, seemed deeply problematic. How is such knowledge even possible? This was the central question Kant wrestled with. Immanuel Kant offered a solution, but it arguably deflated the ambitions of traditional metaphysics. His answer was that synthetic a priori knowledge is possible, but only in a very specific way. It's not about discovering features of the external world itself. Instead, it's about discovering features of the conditions of our own thought and experience. Think about it. Instead of saying causality is a real relation between events in the world, Kant would say something like, human beings, by virtue of how our minds work, must necessarily conceptualize the world around us in causal terms. Similarly, instead of claiming the world is inherently spatio-temporal, he'd say, spatio-temporality is a necessary condition for us to perceive and apprehend the world. Metaphysics, on Kant's view, becomes less about describing the world in the dingenesic and more about describing the architecture of our own cognitive faculties. It's a much more modest enterprise. Interestingly, this challenge isn't just for metaphysics, it arguably applies to all of philosophy. Can we know synthetic a priori truths about ethics or epistemology? Kant's approach suggests a similar deflationary interpretation might be needed there too, which unsurprisingly many philosophers resist. Another way out of the synthetic a priori puzzle is to simply deny that metaphysics fits that description. Maybe metaphysics isn't really about substantive, synthetic claims discovered a priori after all. Perhaps it's mostly about collecting analytic truths, conceptual truths that are true by definition, like bachelors are unmarried men. Or maybe, despite appearances, metaphysics is actually informed by empirical considerations, even if it doesn't always feel that way. This leads to a rather skeptical question. Is there really a distinctively metaphysical way of thinking? Why would such a mode of thought evolve? What evolutionary advantage would there be to contemplating abstract possibilities about universals or causality if those thoughts have no direct impact on survival or reproduction? Whether you believe in universals or nominalism, you're likely to survive just fine. So, why would natural selection favor the development of this kind of abstract, seemingly non-empirical thinking? It starts to look like maybe philosophers are just pulling a confidence trick, carving out a special domain for themselves. So, where does this leave us? How do we navigate the relationship between metaphysics and science? Mumford outlines three main contemporary approaches representing different ways of trying to get our priorities right. These views differ significantly on what metaphysics is and how much it relies on empirical input. Essentially, they represent disagreements about the order of priority. Is metaphysics rationally prior to science? Is it a branch of empirical knowledge, just more abstract? Or are they equal partners? We'll look at these three positions: realism, the Canberra plan, and a posteriorism. Finally, we'll touch on a more widespread conciliatory view that avoids picking a side. First up, realism, championed by thinkers like E.J. Lowe. The core idea here is that metaphysics is the most fundamental form of rational inquiry. It doesn't tell us what there is, but rather what is possible. Science then comes along and tells us which of those possibilities is actual. Think of metaphysics as setting the stage, providing the modal background, the space of possibilities within which scientific discoveries make sense. For example, Lowe argues we could empirically discover that the morning star is identical to the evening star, both Venus, but only if we already have the metaphysical knowledge that two distinct material objects cannot occupy the same place at the same time. That modal claim itself can't be an empirical discovery. Similarly, physics often operates on deep metaphysical assumptions about the nature of objects. Lowe even claims we're all metaphysicians, whether we like it or not. The biggest hurdle for this view, echoing Kant, is explaining how this supposedly a priori modal knowledge is actually acquired. Lowe acknowledges some empirical influence is possible. Science might inform metaphysics, like atomism being supported by physics, but he maintains metaphysics retains its primary, a priori character, sacrificing certainty for relevance. Next, the Canberra Plan, developed by Frank Jackson building on ideas from David Lewis. This approach tries to carve up the work between philosophers and scientists. Philosophers, according to this plan, do the conceptual heavy lifting first. Their job is to gather the platitudes, the seemingly obvious, a priori truths about what something is. For example, for causation, they list properties like relating events, creating constant conjunctions, supporting counterfactuals. These are bundled into a Ramsey sentence, essentially saying there is something that has property F and G and H. This defines the conceptual role of the phenomenon. Then, the second step is for scientists. They take this defined role and empirically investigate what actually fills that role in the world. Maybe it's energy transfer, maybe it's causal powers, whatever. The Canberra Plan argues philosophers play a vital organizational role, setting constraints for scientific theories. However, it faces criticisms. Firstly, gathering platitudes seems like a relatively uninteresting task compared to the complex debates metaphysicians actually engage in, which often revolve around satisfying the Ramsey sentence, not defining the terms. Secondly, it makes metaphysics seem slave to common sense, as the platitudes are usually drawn from pre-philosophical intuitions rather than challenging or refining them, which is a hallmark of the Socratic tradition. The third option Mumford discusses is a posteriorism. This view gains traction when we consider challenges to the analytic-synthetic distinction, Quine and arguments for a posteriori necessity, Putnam. Putnam famously argued that seemingly necessary truths like cats or animals could turn out to be false upon empirical investigate. What if cats were actually sophisticated robots? If that's possible, what's left for metaphysics traditionally seen as a priori? One response is to redefine metaphysics. It could still be a substantive study, but now understood as a posteriori. The division wouldn't be empirical versus a priori, but rather concrete versus abstract. Metaphysics would be continuous with physics, but operating at a higher level of abstraction. Scientists gather specific empirical data, laws of gravity, electromagnetism, and metaphysicians step back to reflect on these findings, forming a global abstract view. They ask questions like, what general features must laws of nature possess? What role do they play? In this view, science is prior to metaphysics. The challenge remains, how can this abstract, a posteriori metaphysics like knowing that distinct objects can't occupy the same space, provide the necessary background for concrete empirical knowledge like the identity of the morning and evening star? This is tough for strict empiricists who deny the modal dimension of knowledge. Finally, many contemporary metaphysicians adopt a non-aligned conciliatory stance. Rather than committing fully to realism, the Canberra Plan, or a posteriorism, they focus on the practical aspects of doing metaphysics. Since metaphysics is largely judged to be non-empirical, the best approach is careful, rational argumentation. As David Armstrong puts it, we shouldn't expect certainties. The goal is to survey the field, weigh the arguments for and against different views, and make a fallible judgment backed by the best reasoning available. This involves a kind of cost-benefit analysis, comparing the strengths and weaknesses of different theories, considering intellectual economy, preferring simpler explanations with fewer entities. Echoing Occam's razor. While pragmatic and reasonable, this approach might deliver a kind of coherence-based truth as consistency within a framework. But for those seeking the substantive correspondence-based truth about reality that realists aim for, this might feel insufficient. Alright, shifting gears slightly, but staying connected, we delve into philosophy of language, specifically focusing on meaning and reference. Why is this crucial for philosophy of science? Because disputes about language, truth, and reality are deeply intertwined. How we understand meaning and reference affects everything from necessary truths to essentialism to whether different scientific theories can even be compared. The core issue is the distinction between meaning and reference. Think about terms like connotation or denotation, sense or reference, intention or extension, different labels for the same basic idea. The classic example illustrating this distinction is renate creature with a kidney and chordate creature with a heart. Assuming hearts and kidneys always go together, both terms refer to the same set of creatures. The extension is the same. Yet, clearly they mean something different. The intention or sense is different. Another famous example is morning star and evening star. Both refer to Venus, but they mean different things based on how we typically pick them out. Let's start with proper names, like Aristotle or Cicero. John Stuart Mill had a simple view: proper names just denote or refer to individuals. They don't connote or express any properties. Think of them as just labels. But this ran into trouble. How do names manage to refer consistently? And why does Cicero refer to the historical figure and not some random person named Cicero? Gottlob Frege delivered a powerful critique in his famous paper, Über Sinn und Beten. He pointed out that sentences like Hesperus is Hesperus, meaning Venus is Venus, seem trivial and a priori, while Hesperus is Phosphorus, meaning Venus is Venus, provides valuable new knowledge and is empirical. Since only the names differ, Frege concluded the names must differ in sense. The sense of a name is the mode of presentation of its referent. Understanding a name means grasping its sense. Frege argued that sense determines reference, and this gave a unified account. Both names and common nouns work by having a sense, a concept, or description that picks out a referent. This was a hugely influential idea. Frege's single description view, where a name's sense is tied to one specific defining property or description, also faced difficulties. Take Aristotle. If his name meant the pupil of Plato and teacher of Alexander the Great, then it would be necessarily true that Aristotle taught Alexander, and we couldn't be mistaken about it. But we clearly could be mistaken, and necessity seems the wrong fit. This led to the cluster theory advocated by Searle and Strawson. Instead of one rigid definition, names are associated with a cluster of salient properties or descriptions. Reference is fixed by finding something that satisfies most of these descriptions. This allows for contingency and the possibility of error. Aristotle might not have taught Alexander, or he might not have been Plato's pupil. It also avoids demanding a full, precise definition. The theory acknowledges vagueness. How many descriptions need to apply? Proponents often saw this imprecision as a feature, reflecting the fuzziness of ordinary language. But the cluster theory also faced challenges. Saul Kripke and others launched a major assault on all versions of description theories, leading to what's often called the new theory of reference. Kripke used modal arguments. If Aristotle taught Alexander were necessary because it was part of the meaning, then it would be impossible for Aristotle to exist without teaching Alexander. But intuition suggests otherwise. Maybe Aristotle was prevented by fate or circumstance. Conversely, the fact that Hesperus is Phosphorus was discovered empirically, not known a priori, suggests it's contingent, not necessary. Donnellan provided examples showing speakers can use names correctly without knowing or intending to fit a descriptive definition. You can call someone Cicero without knowing their historical deeds. Kripke introduced the crucial concept of rigid designation. Names pick out the same object across all possible worlds where that object exists. Descriptions, however, can vary across worlds. The discoverer of oxygen might not exist in some possible worlds. These arguments significantly weakened description theories and paved the way for alternative accounts. Similar arguments were applied to common nouns, especially natural kind terms like lemon, water, tiger, gold. The traditional view, echoing Mill, was that these terms connote properties and have definitions. But Kripke and Putnam challenged this. Putnam's twin Earth thought experiments were particularly influential. Imagine twin Earth, identical to ours, except the liquid they call water is actually XYZ, a different chemical compound, though it looks, tastes, and behaves like H2O. Putnam asks, do Earthlings and twin Earthlings mean the same thing by water? They have the same psychological states, the same beliefs about water, but they refer to different substances. This implies meaning isn't just internal, it's external. It also challenges the idea that dictionary definitions capture necessary essences. Lemons might not be yellow everywhere, and cats or animals might be false if cats were Martian spies. However, Kripke and Putnam also endorsed a form of essentialism. Things do have deep empirically discoverable essence: biological DNA for tigers, atomic number for gold, H2O for water. This leads to the controversial idea of necessary a posteriori truths. Water is H3O is necessary because water is H3O, but we only discovered this empirically. Let's linger on Putnam's twin Earth example, as it's so pivotal. The setup is stark: two planets, identical, except for the molecular composition of the liquid called water. Earthlings call theirs H2O, twin Earthlings call theirs XYZ. Putnam asks us to compare typical speakers on both planets, saying 1750 before the discovery of H2O. He argues they'd be in the exact same psychological state regarding their term water. They have the same beliefs, the same concepts, but they refer to different liquids. This leads to the radical conclusion that reference isn't determined solely by what's inside our heads. Meaning ain't in the head, as Putnam famously put it. Reference depends on external factors, the causal history of the term, the environment, social context. This is semantic externalism. It leads to distinguishing narrow meaning, internal psychological state, from wide meaning, narrow meaning plus external factors determining reference. Tyler Burge extended this further, showing social context matters too, using examples like arthritis. If someone believes arthritis can affect muscles, they might refer to arthritis differently, even if they have the same internal state as someone who knows it only affects joints. The acceptance of necessary a posteriori truths and contingent a priori truths, stemming from Kripke and Putnam, provoked resistance among some philosophers. Some felt this undermined the very idea of philosophy as a priori conceptual analysis. In response, a movement called two-dimensionalism emerged, aiming to rescue a version of the traditional picture. The core idea developed by Jackson and Chalmers is that meaning has two dimensions, leading to two different propositions expressed by a sentence like water is H2O. First, there's the primary intention linked to the concept of water as the watery stuff we encounter. This picks out HRO in our world, but XYZ on twin Earth. The proposition expressed here is contingent. The watery stuff of our acquaintance equals HRO. This is a posteriori. Second, there's the secondary intention, linked to the rigid designation of water. Using a technical device like actual water, this picks out H2O in all possible worlds. The proposition expressed here is necessary. H2O equals H2O. This is necessary a priori. Two-dimensionalists argue that when we utter water is HRO, we're expressing the primary proposition, which is contingent and a posteriori. But the necessity we intuited relates to the secondary proposition. It's an ingenious attempt to reconcile intuition with the empirical findings of reference theory. These debates about meaning and reference have significant consequences for understanding how scientific theories change and whether they can be compared. Consider holism. If we adopt an extreme holistic view, where every belief in a theory contributes to the meaning of every term, then any change in the theory changes the meaning of all its terms. This leads to radical conclusions. Improved successor theories might just be new theories with different meanings, and any two theories differing in any way are incommensurable. However, this seems counterintuitive. Many resist holism by restricting which beliefs contribute to meaning. Others point to the meaning-reference distinction. Just because two terms have different meanings doesn't mean they refer to different things. Renate and Corday show we can have different meanings for the same referent. Perhaps different scientific theories can also be about the same thing, even with different meanings. Hartree-Field developed this further with partial reference, suggesting scientific terms like gene might partially refer to multiple candidate cisterns, recons in different ways, allowing older statements about genes to retain truth values even if no single entity perfectly matches the old definition. So, as we've seen, pinning down the exact relationship between metaphysics and science, and indeed the very nature of metaphysics itself, remains a profoundly challenging task. Various attempts to draw lines or establish criteria have encountered significant obstacles. Understanding the intricate dance between meaning, reference, and empirical knowledge is absolutely essential for navigating these complex philosophical waters. The puzzle of synthetic a priori knowledge, the role of concepts, and the nature of theoretical terms continue to be central battlegrounds in the ongoing quest to understand the foundations of knowledge.